Hello everyone, my name is Jack Sillen. I am a student at Cornell University, and I'm making this video to outline a method of atmospheric analysis that I found to be quite useful when following winter storms off the East Coast, but you can apply it to any type of forecast scenario that you might be interested in. So what we're going to do in a nutshell is basically verify short-range numerical weather prediction forecasts against RAOB data, and then see what those errors, where they occur, might mean for the forecast down the line. So if you're familiar with the Stony Brook Ensemble sensitivity dashboard, this is going to be looking very familiar to you. For those who aren't, this basically is just going to tell us where uncertainty in Ensemble forecasts is coming from. So that's what we're going to use this for. We're going to start out by selecting our domain and time period of interest. Right now that's day 3 off the US East Coast. So we're going to check out this summary graphic, and what this tells you is just a quick look at ensemble mean ensemble mean pressure field. Right, there's our low in question, and then the spread in the ensemble field, and you'll notice that the spread is maximized northwest of the mean low position. That tells us that we have questions surrounding the track and intensity of our potential coastal storm. Surprise, surprise, right? The next thing we're going to do is look at these little EOF subpanels. What's going on under the hood here is interesting sort of verification or analysis scheme. You don't really need to know all the details of it. I, to be perfectly honest, do not know all the details of what's happening under the hood here. But what we're going to focus on is just that you can think of this EOF1, EOF2, EOF3 as some group of ensemble members that have pressures either higher or lower than the mean, right? So EOF1 is this group of ensemble members that has pressures much, much higher than the mean here east of Cape Cod. That indicates a much weaker coastal storm. So what needs to happen at the 500 millibar level for this group of ensemble members forecasting a weaker storm to end up being correct? Well, to answer that question, we're going to go back out to the dashboard. We're going to go to EOF1, 500 hectopascals, day 3, loop. So this is going to tell you what height anomalies will produce that EOF1 signature at the surface. That EOF1 signature, remember, being the weaker storm. So what needs to happen at 500 millibars to get this weaker storm outcome? Well, 3 days from now, what needs to happen is you need to have a weaker downstream ridge, right? Lots of negative height anomalies here downstream of our low, and you need to have lots of positive height anomalies in the trough itself, especially in the shortwave trough responsible for producing the storm. That's pretty intuitive, right? Now, what we can do now is follow this backwards through time to see where, what signals we might be looking for, say, 24 hours before the storm. So if 24 hours before the storm, heights are higher than expected over the southern plains within our shortwave trough of interest, and heights are lower out over the Great Lakes and Mid-Atlantic ahead of our trough, that means that EOF1, that weaker storm outcome, is going to be more likely. Again, this makes good sense from our intuition of a lower amplitude flow is going to produce a weaker storm. So that's a little good sanity check there. We can keep following this back and now say 48 hours before the storm, right? This is the February 5th at 0Z, so this would be this evening. The evening of the 4th. You can see that we have this this big positive height anomaly here over the Intermountain West. So what this is telling you is that if heights are higher than expected over this region, right? This is their shortwave trough of interest. 1 day after the 5th at 0Z, right? So that's going to be 0Z the 6th. If at that time heights are higher than expected in this region, that EOF1 outcome becomes more likely. Again, that makes dynamic sense. If our shortwave is weaker, our storm is probably going to be weaker too. So now we can back that all the way up to 12Z on the 5th, right? So 0Z plus half a day. And we can see that we have strong negative height anomalies here over Alaska associated with this weaker storm outcome, and positive anomalies over British Columbia associated with this weaker storm outcome. Again, dynamically, this makes good sense. If the upstream ridge is weaker and the shortwave trough is weaker, then you're going to have a weaker storm. So, with that in mind, we want to answer the question, is that actually happening? Well, to do that, we can head on over to the little verification graphics that I developed. These are not super fancy by any means, but it's a useful tool. I am working to get these available for public use, hopefully within not too long, but for now I'll just be posting them on Twitter during periods of interest. So our two questions are, what are heights doing over Alaska, and what are heights doing over British Columbia? And those questions we know to ask because of the ensemble sensitivity analysis we just did. So over Alaska, we can see over all these RAOB sites, heights are somewhere between 3 and 20 meters above the GFS forecast. Take any one observation here with a grain of salt, especially if the signal is a relatively low magnitude. But because we have this 1, 2, 3, 4, 5, 6 stations reporting a significant anomaly being greater than 10 meters, we have pretty high confidence, in my opinion, that this is a legitimate signal. So heights are higher than expected in the upstream ridge over Alaska. And then in our shortwave trough, heights here at ZXS and CWVK, two upper air sites here in British Columbia, heights are more than 15 meters below the GFS forecast. So that means that in the observations, our shortwave trough is stronger than expected. Our upstream ridge is also stronger than expected, and that anti-correlates with the EOF1 outcome that we saw over here, portraying a weaker storm. So, with that in mind, that's how you can come to the conclusion that current observational trends are likely favoring a more amplified solution, with the East Coast winter storm expected on Sunday the 8th. Sunday the 7th. It's 0Z the 8th that we're looking at here. And then as one last quick little check, it's fun to look at some of the new forecast model guidance. Right, we'll flip on over to the 500 millibar level here. And the trend in forecast model guidance, this is the NAM, is for that shortwave trough to be stronger at the short lead times here. That matches up with the observations we just analyzed. Then what happens later? Well, unsurprisingly, you end up with a more amplified wave over the East Coast on Sunday, and a corresponding northwest shift in the surface low position and the precipitation shield. Right, so that's the old run, that's the new run. So that model trend seems to have some legs to it based on the observational data we've been looking at. This method is nowhere near perfect. There's a lot of subjectivity here, but I found it to be a useful tool in anticipating model trends in the medium range. That's it for now. If you have any questions, definitely feel free to reach out and let me know. Thanks so much for watching. Have a good day.